In this video, we're going to be taking a look at a conical pendulum problem, which is similar to the classic tetherball problem as well. Now, the reason why this problem is quite difficult is because they're generally presented with what seems like very little information. For example, this one, we have a mass of 1 kilogram and a rope length of 0.5 meters. Now, if we were to solve for this, there's a lot of different steps we need to get to in order to solve for the tension and the velocity, but at first that seems like not enough information to solve the problem. So the main idea we're looking at is if we take a sum of all of the forces, it's going to equal mv squared over r for anything that's moving in circular motion, which is basically m times a. We have the m here, and then the a is the v squared over r, which is known as the centripetal acceleration. Now, the key to solving this problem is two different things, and both of which are creating a triangle and doing some simple trigonometry. So in order to solve a problem like this, the first thing I'm going to do is draw my forces acting on my mass first. So we have the force of gravity straight down, and then we have the force of tension pulling it up on an angle. And that's basically it. Okay, now just like anything else that we have on an angle, we want to make sure we create an x component and then also create a y component as well, which we'll call ftx and fty. So let's go ahead and create two different formulas to sum up the forces in the x and y direction and see what we come up from there. All right, so we summed up our forces in the x and y direction, and we came up with two formulas. This one equaling 0 because there is no movement or acceleration in the vertical direction. And then along the horizontal axis, we have an imbalance of force because we only have the ftx, and that equals mv squared over r because that is our centripetal force. Now, if we were to look at the top view, if we were to look straight down at this conical pendulum, what it would look like is it would look like a circular path going around the stand or the pole, and then this would be where the pole is as the ball is moving around in a circle. Now, that force of tension would be pointing towards the center. So that is the centripetal force, and anything pointing towards the center of the circle is a positive force. Anything pointing away from the center of the circle would be a negative force. So we just have this positive centripetal force equal to that mv squared over r. Now, again, it still looks like we don't have too much information, and like I said, the key is drawing two triangles, which we will get to shortly. Now, anytime you have your formulas, what you want to do is basically just plug in any number of values you possibly can in order to solve the problem, and then that will actually take you, hopefully, in the direction that you're looking for. So as I'm looking at it now, I really only have a rope of 0.5 meters that doesn't look like it could be directly plugged in anywhere. And then I have the mass of 1 kilogram. That's going to help me find my FG. So my FG is mg, mass times 9.8. Now, if my FG is 1 times 9.8, which is obviously 9.8 newtons, that means our FTY is also 9.8 newtons. So that's going to be pretty significant to us. Our FTY equals 9.8 newtons. If I look at the second part, do I know FTX? No. Do I know the mass? I do know the mass is 1. And then again, we are not very close to a solution there. Now, anytime you have one side of a triangle along with an angle, that's good news because you can solve for all the different parts of the triangle. So this is where the key part comes in, where we can go ahead and draw our two triangles. So first, we're going to draw our force triangle, which looks like this right over here. And we know that the FT y is 9.8 newtons. So if we know that this is 9.8 newtons, we want this ftx because it's part of our formula. So we have the 30-degree angle, and then we have the adjacent side, and we want the opposite side. So we're going to want to use tangent. So the tangent of 30 degrees equals the opposite end, which is the ftx, over the adjacent end, which is the fty. So we have 9.8 newtons on the bottom. And then we can go ahead and multiply both sides by 9.8 newtons, and then our ftx comes out to 5.66 newtons. So that's good news for us. So we did want this value right over here. Now, the second triangle we're going to set up is actually one of different distances or lengths. So we have a rope length of 0.5 meters. Now, the reason why that's significant is because we want a distance from this triangle, and that distance is the radius. So let's go ahead and draw another triangle off to the side. So we have a 0.5 meter hypotenuse because that is the actual string right there. There's our 30-degree angle still. And then this distance over here is the radius of our circular path. So we want the opposite end, and we have the hypotenuse. So we're going to go ahead and use the sine of 30 degrees, and then that's going to equal the opposite over the hypotenuse. And then again, multiply both sides by 0.5, and then that's going to leave us with the radius of 0.25 meters. All right, so it looks like we have everything we need now because this one is 0.25 meters. So if we wanted to solve for everything we need, we can go ahead and solve for that velocity first. It doesn't matter. We could solve for the tension first or the velocity first. So let's go ahead and solve for the velocity first. We're going to take the 5.66, multiply both sides by 0.25, and then that 1 is not going to be significant mathematically, and then square root both sides, and then that gives us a velocity of 1.14 meters per second. Oh, actually, that's 1.19 meters per second. All right, so we are good with our velocity now. We could have solved for our tension earlier, so let's go ahead and slide back to our force triangle and finish solving that. So we already know that FTY is 9.8, and we know FTX is 5.66 newtons. So we could use either of those two sides in combination with the 30-degree angle in order to get our hypotenuse of the triangle, which is RFT. So let's go ahead and use cosine, but as I said before, it doesn't really matter. Cosine of 30 degrees equals the adjacent side, which is the 9.8 newtons, over the hypotenuse side, which is the FT. And then we're going to go ahead and cross multiply these two. And that would leave us with a final tension of 11.32 newtons. So as I said before, this problem can seem a little intimidating because of the lack of information in it, but once you start setting up values and then plugging them in and then solving for different parts of your two triangles, it will slowly lead you towards your solution, and then you can get your FT and your V. So I hope that was helpful to you. Thank you for watching, and